Alright, here's another quiz or test type problem. Let's pay close attention to the details that I'm going to talk about when we're solving a problem like this, because a lot of the wording and the details are required and are really necessary in order to answer this question. Start by plotting our original triangle. They gave us the coordinates for A, B, C, so we go ahead and we plot that. So we make sure that we're very accurate with where we plot those points, and we label them A, B, and C. Next, we're going to dilate with the scale factor of 2. That means I'm going to multiply each of my three coordinates by 2. So A prime moves to 6, 8. B prime stays at 0, 0, because 0 times 2 is 0. And C prime moves to 8, negative 10. Then we go ahead, plot, and label those points as well. At this point, we really have to answer one question and then give mathematical proof explaining why it is true or not true. They want to know if the triangles are similar. We have triangle ABC, the original, and then we have triangle A prime, B prime, C prime, that new triangle. And these are going to be similar, and we really have talked about just one major way to show or explain why they are similar, and that's angle-angle similarity. So we can go ahead right away and state that triangle ABC is similar to triangle A prime, B prime, C prime by angle-angle similarity. That's answering this question and explaining why, but we haven't shown any mathematical proof yet. That's the key to this problem. We have to show mathematical proof as to why these are true, or why these are similar. Angle-angle similarity, remember, means I need to show that I have two congruent angle pairs. So I've got to find two congruent angle pairs in this, comparing a triangle ABC to triangle A prime, B prime, C prime. One of those angle pairs is actually relatively easy if we can recognize it, and that's they both have this angle, angle B or angle B prime. Okay? So I like to state that angle B is congruent to angle B prime and state why. Just like when in our proof unit, we have to understand why that's true, okay, by the reflexive property. They are the exact same angle from one triangle to the other. That one is the more straightforward answer. The other one is a little bit trickier. What we're going to have to show, so I like to show that's the reflexive property, is that either angle A prime is congruent to angle BAC, or that angle C prime is congruent to angle BCA. It's true, and so we can state that. For example, I can state angle A prime is congruent to angle BAC, but we have to state why and show evidence why. Now, they are at the exact same location of two intersections, so they're corresponding angles, which we know are congruent if our lines are parallel. So I can state that these are congruent because they are corresponding angles of parallel lines. But don't stop now, because we now have one more step to do. We have to prove that they're parallel lines. That's the mathematical proof. Just doing this doesn't show that they're parallel lines. We have to prove that they're parallel lines. So we talk about the slopes, because if the slopes are identical, then we have mathematical proof that those lines are parallel. So I'm going to calculate the slope of segment AC, or you can just count it out. From A to C is down 4, down another 5 is down 9, and right 1. That's a slope of negative 9 over 1. So if you show me the slope, that's mathematical proof. Okay? Whether you write it out up here, use the slope formula, doesn't matter to me, as long as you can tell me that is the slope. And then also the slope of A prime C prime. Segment A prime, segment A prime C prime, that goes down 8 and then down another 10, that's down 18, and then it goes to the right 2, which simplifies to negative 9 over 1. Same slope, that's why they're parallel lines. So, summary. Plot the first triangle, plot the second triangle. Similarity statement reason. And if you're giving that reason, you need to have two angle congruent pairs and why they're congruent. One of those angle congruent pairs will basically have to deal with parallel lines. So the mathematical proof I need to see on a problem like this is that you found the slope of those parallel lines and that it is exactly the same.